Good afternoon, children. Good afternoon, everybody. Yesterday, we have completed the classification of elements into blacks. Some bits also completed in this topic, classification of elements into blacks. So, continue the topic, periodic classification of elements, ionization, enthalpy. What is ionization enthalpy? Okay, here part 3, classification of elements. So ionization of enthalpy means a quantitative measure of the tendency of an element to lose electron is given by its ionization enthalpy. It is also known as ionization energy or ionization potential. It units of ionization enthalpy kilojoule per mole or kilocalories per mole or electron volt per atom. 1 electron volt per atom is equal to 96.49 kilojoule per mole. That equal to 23.06 kilocalories per mole. Here, what is first ionization enthalpy? Okay, student, already complete this topic. Just to remember the what is ionization enthalpy and what is the factor affecting of ionization enthalpy. The minimum energy required to remove the electron from the outermost orbits of an isolated gaseous neutral atom is called first ionization energy, is also known as it is represented as IE1. Here X, 1 electron is removed, some amount of energy is required, so it is called as ionization energy. Here see the equation. X gives rise to X plus 1 electron is removed, some amount of energy is required, is called as ionization enthalpy. What is second ionization enthalpy? The energy required to remove the second most loosely bound electron in gaseous state of a unipositive ion is called second ionization enthalpy. Okay, student, here the another 1 electron is removed from unipositive ion is called second ionization enthalpy, IE2. Therefore, X plus another 1 electron is removed, so X plus 2 positive ion, so it is called as second ionization enthalpy. In general, energy is always required to remove electron from an atom or ion, hence ionization enthalpy is always positive. So it is endothermic reaction. Make a note, IE2 is greater than IE1 because it is more difficult to remove an electron from a positive charged ion where the nuclear charge is more than in neutral atoms. So more energy is required. Therefore, IE2 is greater than IE1. Discuss the factor affecting of ionization potential, ionization enthalpy. Number one, atomic size. When atomic size increases, IP value decreases because the attraction of nucleus over the valence electron decreases. Therefore, IP is inversely proportional to atomic size. Here, atomic size increases, IP value decreases. Atomic size decreases, IP value increases. So inversely proportional to the IP is inversely proportional to atomic size. Then next, second factor is nuclear charge. When nuclear charge increases, IP value also increases because the attraction of nucleus over the valence electron increases. So IP value is directly proportional to nuclear charge. This IP value or nuclear charge increases, IP value increases. Nuclear charge decreases, IP value also decreases. Therefore, directly proportional to nuclear charge IP value. Third factor affecting of ionization energy, screening effect. What is screening effect? When screening effect increases, IP value decreases because the attraction of the nucleus over valency cell electron decreases. So IP is inversely proportional to screening effect. So IP value increases, screening effect is decreases. IP value decreases, screening effect increases, inversely proportional to screening effect. Then next, penetrating effect. The tendency of orbit to move towards the nucleus is called penetrating effect. The penetrating effect, the order of penetrating power of orbital is S is greater than P, P is greater than D, D is greater than F. So when penetrating effect increases, IP value increases because attraction of nucleus over the electron is increases. So IP value is directly proportional to penetrating effect. So IE value increases, penetrating effect also increases. It is directly proportional to the effect of IE and indirectly proportional to penetrating effect. Okay, student. Then next, electronic configuration. The atoms of elements having either half-filled or full-filled orbitals are comparatively more stable. Hence, they requires more energy than other. So here, the effect electron configuration is half-filled electronic configuration or full-filled electronic configuration is more stable. So hence, they required more energy than others. So IE of nitrogen is more energy than IE of oxygen because of nitrogen atomic number 7, 1s2, 2s2, 2p3, oxygen atomic number 8, 1s2, 2s2, 2p4. So 2p3, 2p4, nitrogen 2p3, half filled electronic configuration. So more energy than oxygen because of nitrogen valency cell half filled electronic configuration. Here, half filled electronic configuration or fulfilled electronic configuration more stable than others. So nitrogen is the more energy than oxygen. Okay. Then next, trend in ionization energy in a period. In a period from left to right in a periodic table, IE value increases. IE increases across the period from left to right. So the reason the atomic size decreases left to right in across a period, atomic size decreases and effective nuclear charge increases. In a period, IE value increases because of atomic size decreases. Okay, in a period. In a group trend, IE decreases as we move from top to bottom in periodic table. IE decreases because of reason the atomic size increases and effective nuclear charge decreases. So IE value also decreases. Atomic size increases, IE value decreases in a group. Okay. Then next, what is periodic trend in properties of elements? What is periodicity? The repetition of properties of elements at regular interval in the periodic table is known as periodicity, and the properties are known as periodic properties. There are many observable pattern in the physical and chemical properties of element as we come down in a group or move across period in the periodic table. The periodicity, periodic properties, we will discuss the periodic trend in physical properties with respect to number one, atomic size, number two, ionic radius, number three, ionization enthalpy, number four, electron gain enthalpy, number five, electronegativity. Here, the trend in the periodic properties in a group and period. See that the table is very important. Periodic property number one, atomic radius in a group. In the periodic table from top to bottom, in a period from left to right. Okay, atomic size, atomic radius or atomic size in a group increases top to bottom, in a period decreases. So increases in a group because down the group principal quantum number cell is increases, so atomic radius also increases. In a period decreases because The differentiating electron enter into same subcell, so decreases. So number 2, electropositivity in a group increases, in a period decreases. Metallic nature, nothing but electropositivity, nothing but metallic nature increases, in a period decreases. Basic nature of oxide increases and in a period decreases. This is the 4 properties depend upon atomic radius. So don't remember very important point in this periodic properties: atomic radius, electropositivity, metallic nature, basic nature of oxides are in a group increases, in a period decreases. Okay. Then next, ionization potential in a group decreases. Already discussed the ionization potential in group, vary in a groups and period. In a period increases. Electronegativity in a group decreases, in a period left to right increases. Electron gain enthalpy in a group decreases, in a period across left to right increases. Non-metallic nature in a group decreases, in a period increases. Acidic nature of oxides in a group decreases, in a period increases. These properties: ionization potential, electronegativity, electron gain enthalpy, non-metallic nature, acidic nature of oxides, these properties, 5 properties are in a group decreases, in a period increases. Okay, right. Next, diagonal relationship. What is diagonal relationship? The similarities in the chemical properties of first element in second period, with the second element of next group in third period is called diagonal relationship. Either the diagonal relationship here, example, uh, second period, first year group element, third period, second year group element, same physical and chemical properties. So this relationship is called as diagonal relationship. Okay. Some important points of the periodic table: electron affinity. Certain properties of elements are predicted on the basis of values of electron affinity. The elements having high values of electron affinity are capable of accepting electron easily. They form anion and electrovalent compound. Okay, these elements are electronegative in nature. The element having high values of electron affinity act as a strong oxidizing agent, for example, etc. This point is very, very important. The element having high values of electron affinity, act as a strong oxidizing agent. Okay. On the basis of general trends, ionization potential and electron affinity following properties can be predicted. See the chart, see the is very important. Metallic nature decreases. Here, metallic nature and non-metallic nature. Metallic nature decreases in a period. In a period, decreases from left to right. In a group, from top to bottom, increases, while non-metallic nature is reverse. So non-metallic nature decreases in a group from top to bottom, and a period increases from left to right. Okay, arrow mark represents groups. Down arrow mark is a group. Right arrow mark is a period. Okay, right. Here, reducing nature and oxidizing nature. Reducing nature in a period, while oxidizing nature increases. Oxidizing nature increases, reducing nature decreases. The reducing nature increases in a group, so oxidizing nature in a group decreases. Stability of metal increases, while activity of metal decreases in a period. In a group, stability decreases while activity increases. See the table, see the chart. Stability of metal and activity of metal. Stability of metal in a group from top to bottom decreases. Activity of metal is increases. Stability of metal in a period left to right increases. Activity of metal decreases. This trend is observed especially in first year and second year and third year group element. And this is some key points, basic concept of ionization, enthalpy, and periodicity. Periodic properties, trends vary in a groups and period. Okay, student, some objective type bits in this topic are given. So first question, the group of element with second highest ionization energy is, second highest ionization energy is number one, second A group, number two, zero group, number three, seventh A group, number four, first A group. After first A group, valency cell NS1. After one electron is removed, so to get nearest noble gases electronic configuration, so first A group loss of one electron, second A group two electron, seventh A group gain of one electron. So first A group removing of one electron, element get nearest electronic configuration. So second highest ionization energy is first A group element. Okay. Then next question, student. Generally, the ionization potential in period, ionization potential from left to right in a period increases, but there are some exception. The one which is not exception is, so number one, beryllium and boron, number two, nitrogen and oxygen, number three, magnesium and aluminium, number four, sodium and magnesium. So here sodium to magnesium, sodium, magnesium, aluminium, like that. Okay. So sodium to magnesium IP value increases normally. So here the question, ionization potential in a period increases, but there are some exception. The one which is not exception is, so that is fourth one option is the right option. Sodium to magnesium IP increases normally. So fourth one is the right answer, right, student? Okay. Then next here, how many ionization energies can carbon have? Carbon have electronic configuration. Carbon 6 atomic number, 1s2, 2s2, 2p2. So 2px1, 2py1. Excited state configuration, 1s2, 2s1, 2px1, 2py1, 2pz1. Okay. Here total number of electrons, 2, 3, 3, 4, 5, 6, 6 electrons, atomic number 6. So option 1, 2, 4, 6. Here with sufficient energy supplied, all 6 electron of carbon. So electron answer is the fourth one is the correct option. When the sufficient energy is supplied, all the 6 electrons of carbon can be removed. So fourth one, 6 is the right option. First ionization potential of magnesium is greater than aluminium. First ionization potential, magnesium is greater than aluminium. Reason. Okay. Number one, aluminium atom is very large when compared to magnesium. Second option, aluminium has a stable electronic configuration. Third option, magnesium has stable electronic configuration. Fourth one, the electron affinity of magnesium is positive, is energy is absorbed. Due to stable configuration of magnesium, atomic number is 12. So 1s2, 2s2, 2p6, 3s2. Aluminium atomic number 13. So configuration is 1s2, 2s2, 2p6, 3s1, 3s2, 3p1. So valence cell 3s2, 3p1, 3s2. So here loss of 2 electron magnesium to get nearest noble gas electronic configuration. So stable electronic configuration is magnesium, stable electron configuration, then aluminium. Because of magnesium valency cell, total number of electron valence cell 2, here aluminium valence cell 3. Here loss of 2 electron get nearest noble gas electronic configuration. Here aluminium loss of 3 electrons. So magnesium has a stable electronic configuration than aluminium in this question. Okay. Next. Electron with highest penetrating power are, here already IE value factor affecting of ionization potential, that is extent of penetrating orbital of valence electron. So what is penetrating effect for a given principal quantum number n? Due to spherical shape, s orbital penetrates more towards the nucleus, so s electron required large amount of energies for its removal. On the other hand, due to dumbbell shape D and dumbbell p orbital, double dumbbell d orbital. Okay, here penetrating power of orbital depend upon shape of the orbital. So here p orbital, s electron, p electron, s electron, d electron, and f electron. So hence ionization enthalpy follows sequence extend. So S is greater than P, P is greater than D, D is greater than F. So electrons are close to the nucleus, order of penetrating power is S is greater than P, P is greater than D, D is greater than F. Therefore, S electron is highest penetrating power of orbital. Okay, highest penetrating power of orbital due to this disappeared shape and low penetrating ability of D and F electron required still lesser energy for their removal. Hence, the ionization enthalpy follows the sequence of the extent of penetrating orbital. S is greater than P, P is greater than D, D is greater than F. Okay, right. Next. Element that has highest first ionization energy among the following is number one, calcium, magnesium, aluminium, silicon. Here, calcium 20, 12, 13, 14. So, due to small size, silicon has high IP value. So, second one, fourth one is the right option. Then next question. The element that processes the lowest ionization energy among the following. Number one, oxygen. Second one, fluorine. Third one, sulfur. Fourth option is nitrogen. So what is the question? Lowest ionization energy among the following. Oxygen, fluorine, nitrogen. So here, sulfur, oxygen, sulfur, fluorine, chlorine, nitrogen, phosphorus. So sulfur is a large size than oxygen, fluorine, nitrogen. So large size of sulfur has low ionization potential, low ionization energy than other three options: oxygen, fluorine, nitrogen. So third option is the right option. Right. Next question. Atoms of the following group processes, atoms of the following group processes, the highest ionization energies, highest ionization energies, number one, first A group, number two, second A group, number three, fifth A group, number four, zero group. So here zero group due to stable electronic configuration because of the do not sharing of electron or gaining of electron or loss of electron. So stable configuration of zero group element have highest ionization energy is zero group element. Okay, right student. Okay student, right. Then next question. Atoms of the following group processes the lowest ionization energies. The lowest ionization energies, first A group, second A group, third option is fifth A group, fourth option is zero group. Here, first A group element gets stable configuration because of after losing of one electron. Second A group, losing of two electron, stable electronic configuration. Fifth A group, gaining of three electron or loss of gaining of electrons. So here loss of one electron first A group element. So lowest ionization energy is a first A group element. Okay, right. Next one. Which of the following element with the given electronic configuration with processes lowest first ionization energy, lowest first ionization energy. Number one, 1s2, 2s2, 2p6, 3s1. Second one, 1s2, 2s2, 2p5. Third option is 1s2, 2s2, 2p6. Fourth one option, 1s2, 2s2, 2p6, 3s2, 3p2. Here 10, 11, here 9, so 10, here 14. So the question is, which of the following element is given electronic configuration will processes lowest first ionization energy? Ionization energy means removing of one electron. So element with configuration 1s2, 2s2, 2p6, 3s1. Valency cell 4 option 3s1, 2p6, 2p5, 3p1, 3p2. So element with configuration 3s1 gets stable configuration after lossing of one electron. So first option is the right option. So that is 1s2, 2s2, 2p6, 3s1. Okay, right. Then next question. I1 of an element X is 899 kilojoule per mole, and that of another element Y is 801 kilojoule per mole. Then X and Y may be number one, lithium and beryllium. Second option, beryllium boron. Third option is boron carbon. Fourth option is carbon nitrogen. Here beryllium boron IP. Beryllium is more than boron due to stable configuration of beryllium 1s2, 2s2. So stable configuration of beryllium and boron. Second option is the right option. Right. Okay. Next, configuration of element with the highest ionization energy is number one, neon 3s1, neon 3s2, 3p3. Third option, neon 3d10, 4s2, 4p3. Fourth option is neon 3s2, 3p4. Here, due to number one, 3s1, number two, 3s2, 3p3, number four, 4s2, 4p3, 3d10, 3s2, 3p4, half-filled configuration 3s2, 3p3, it has high ionization potential. So half-filled electronic configuration is more ionization energy. So that is second one is the right option, neon 3s2, 3p3. Okay, right. Electron affinity is measured in. Electron affinity is measured in. What is electron affinity, student? This is properties of isolated atom. It is energy released when an electron is added to an atom. The energy indicated in terms of electron affinity. So simply the amount of energy released when an electron is added to neutral gaseous atom to convert into negative ion. So it is called as electron affinity. So electron affinity units, number one, no units. Number two, kilocalories per mole. Third option is kilojoule per mole. Fourth option is both second and third. Here, the electron affinity units electron volt or kilojoule per mole or kilocalories per mole. So here both 2 and 3. Second one, kilocalories per mole, right option, as well as kilojoule per mole, also correct option. So electron affinity is measured in both second and third, kilocalories per mole and kilojoule per mole. Okay, right. Next, in a period from left to right, electron affinity in a period. Number one, increases. Number two, decreases. Number three, remains constant. Number four, first increases and then decreases. Here as the atomic size decreases in a period from left to right, nuclear attraction of the valency cell increases and electron affinity also increases. So depend upon atomic size. Atomic size decreases, nuclear charge increases, and electron affinity increases. So in a period from left to right, electron affinity increases. So first option is the correct option. Electron affinity in a period from left to right increases. Student, okay. Already complete the periodic properties. The follow the table, that is the properties of following periodic properties. Okay. Then next, electron affinity is, what is electron affinity? Number one, first option is, first one, energy required to take out an electron from an isolated gaseous atom. Second option, the tendency of an atom to attract an electron toward itself. Third option, energy absorbed when an electron is added to an isolated atom in gaseous state. Energy released when an electron is added to an isolated atom in gaseous state. Generally, electron affinity or electron gain enthalpy, it means the amount of energy released. Energy is released when an electron is added to neutral gaseous atom to convert into a negative ion is called as electron affinity. In the following four options, fourth one is the right option because of energy is released. Energy is released when an electron is added to an isolated atom in the gaseous state. So that is the correct option. Electron affinity is okay. Right. Next question. Electron affinity of fluorine is less than that chlorine because electron affinity of fluorine is less than that of chlorine because number one, electronegativity of fluorine is more. Okay. Second one, 2 2p subcell of fluorine is smaller. Third option is chlorine is stronger oxidant. Fourth option is bond dissociation energy of F2 is less. Okay. Here, fluorine is less than that of chlorine because of due to the small size of fluorine than chlorine. So inter electronic repulsion are more. So 2p subcell of fluorine is smaller. Therefore, fluorine is less than that of chlorine because of small size of fluorine. Small size of fluorine. Okay. Right. Next. Ionization energy of fluoride F minus is equal is magnitude with the electron affinity of F minus, F, F plus 2. Both are same magnitude, F minus and F. So second option is the right option. Next, when an electron is added, energy is absorbed in which of following? Electron is added, energy is absorbed in which the following is number one, carbon, nitrogen, fluorine, oxygen. Here nitrogen, due to stable half-filled electronic configuration of nitrogen atom, electron is added when energy is absorbed because of half-filled electronic configuration of nitrogen. Okay. Here, energy is released in the presence of equation. Energy is released. Okay. So number one, Na gives rise to Na plus electron. Energy is next. Second one, O minus plus electron gives rise to O minus 2. Third one, N minus 2 plus electron gives rise to N minus 3. Fourth one, O plus electron gives rise to O minus. In the question is energy is released. So here electron affinity like that. When electron is added to gases atom. So energy is released. So fourth one option is the Correct option. Electron affinity of oxygen atom is exothermic reaction. Exothermic reaction means electron is added to a neutral gaseous atom. So when energy is released, so fourth one is the right option. Okay, right. Next one. Configuration that shows the highest energy released when an electron is added to the atom is, okay, configuration that shows the highest energy released when an electron is added to the atom is number one, 1s2, 2s2, 2p3, 1s2, 2s2, 2p3. Second one, 1s2, 2s2, 2p4. Third one, 1s2, 2s2, 2p5. Fourth one, 1s2, 2s2, 2p6. So here, highest energy released. So 1s2, 2s2, 2p5 to close to octet electronic configuration. So third option is the highest energy released, 1s2, 2s2, 2p5 close to octet electronic configuration. Okay, third one is the right option. Among chalcogen, electron affinity is highest. Chalcogen is a sixth A group element. Sixth A group element, chalcogens, oxygen, sulfur, selenium, tellurium, polonium. So here option oxygen, sulfur, selenium, tellurium. Here our question is chalcogens electron affinity is highest. Electron affinity is highest. So here sulfur is the right option because of due to moderate size of sulfur, electron affinity is high. So second option is sulfur is the correct option because of due to moderate of size of sulfur. Okay. The next, the property of an element that cannot be determined directly but can be obtained indirectly from Born-Haber cycle. Born-Haber cycle. So number one, ionization potential. Number two, electron affinity. Number three, electronegativity. Number four, electropositivity characters. What is that question? An element cannot be determined directly but can be obtained indirectly. Born-Haber cycle. So electron affinity can be obtained Born-Haber cycle. So electron affinity is the right option. Okay. Okay, student. Right. Next. The element with highest electron affinity is the element with highest electron affinity is highest electron affinity. Okay. Number one, fluorine. Number two, cesium. Number three, helium. Number four, chlorine. In chlorine, electron repulsion are less when compared to the fluorine. So chlorine is highest electron affinity because of chlorine. Electron repulsion are less when compared to the fluorine. Fluorine and chlorine. Fluorine is the highest electron affinity. It is due to fluorine has small atomic size than chlorine. Fluorine has strong inter-electronic repulsion. A part the liberation of energy is utilized during the addition of electron fluorine atom to overcome the repulsion. So less energy is liberated than chlorine. So highest electron affinity is uh, chlorine. Fourth one is the right option. Okay. Then next, incorrect statement is incorrect statement. So first statement, fluorine has highest electron affinity. Fluorine has the highest electron affinity. Second one, greater the nuclear charge, greater is the electron affinity. Third option is the electron affinity of nitrogen is positive. It means energy is absorbed. Fourth one, chlorine has highest electron affinity. Incorrect statement. The second, third, fourth statement are correct statement because of greater the nuclear charge, greater is the electron affinity. Third option is the electron affinity of nitrogen is positive. Nitrogen is positive, it means energy is absorbed. Energy is absorbed. So chlorine has highest electron affinity. So incorrect statement is a fluorine has the highest electron affinity. So solution chlorine is the element with highest electron affinity. The fourth one, chlorine is highest electron affinity, but not highest electron affinity of fluorine is a incorrect statement. Okay, right. Okay, student, listen carefully. Electronegativity is measured in. Electronegativity is measured in. What is electronegativity, student? It is the a pair of electrons shared between two atoms. Unequal sharing of electron result heteroatomic molecule. In these molecule, one of these two atoms attract the shared electron pair more towards itself. This property is known as electronegativity. Electronegativity, the tendency of the atom of element to attract shared pair of electron more towards itself in a heteronuclear diatomic molecule or in a polar covalent bond. Here, electronegativity question is electronegativity is measured in number one, no units, number two, kilocalories per mole, number three, kilojoule per mole, number four, both second and third. Here, electronegativity, it has no units. It has no units because it is relative properties. It is relative properties. So it has no units of electronegativity. So first option is the right option. Electronegativity, no units. Okay. Then next question. The electronegativity of the following elements increase in the order. Electronegativity following elements in the order. Number one, carbon, nitrogen, silicon, phosphorus. Carbon, nitrogen, silicon, phosphorus. Incorrect order. Nitrogen. Second one, silicon, carbon, phosphorus. Okay. Next one, silicon, phosphorus, carbon, nitrogen. Fourth one, phosphorus, silicon, nitrogen, carbon. Down the group, electronegativity decreases, across a period increases. So silicon, phosphorus, carbon, nitrogen is the right order. So third option is the correct correct order. Silicon, phosphorus, carbon, and nitrogen. Okay. Pauling scale of electronegativity is based on. Here, electronegativity two scale. Number one, Pauling scale and Mulliken scale. Okay. What is Pauling scale and Mulliken scale? Here the question, Pauling scale of electronegatives is based on number one, electron affinity, number two, ionization potential, number three, both IP and EA. Number four, bond energies. What is Pauling scale, student? Pauling scale proposed by Linus Pauling to measure the electronegativity. This scale based on the values of bond energies only. Bond energy, the bond energy of compared to A, B is taken as the average of the bond energy A and B molecule, that equal to electron affinity is equal to EAA into EBB whole to 4 of 1 by 2. The experimental determined the to calculated the value of electron negativity. So Pauling scale depend upon the Pauling scale is a measured electronegativity value of bond energies. So fourth one is the right option, bond energies. Okay. Then next, The electronegativity of an element is the average of its ionization energy and electron affinity according to electronegativity. Next scale, Mulliken scale. Mulliken scale. Mulliken indicated the electronegativity of element is the average of its ionization energy and electron affinity. So electronegativity is equal to ionization enthalpy plus electron affinity by 2. Mulliken's electronegativity values are almost 2.8 times larger than the Pauling values. The Pauling values are obtained from the following relations. That is equal to Mulliken scale electronegativity is equal to IP plus E by 5.6 in electron volt. So Mulliken scale is applied to monovalent atom and does not cover multivalent atom. Okay. The question is electronegativity of element is the average of its ionization energy and electron affinity according to Pauling and Rutherford and Bohr Mulliken. Mulliken is the right option. Mulliken scale is equal to Mulliken scale of electronegativity is equal to IP plus EA by 2, that equal to IP ionization energy and plus electron affinity by 5.6 in electron volt. Okay, right. Next, the electronegativity value according to Mulliken scale are times dash times the values in Pauling scale. Okay, here the Mulliken scale and Pauling scale. So option 0.208, second one option 2, third one option 2.8, third option is 544. Okay, the Mulliken scale is applied into monovalent atom, does not apply to multivalent atom. Okay, Mulliken's electronegativity values are almost 2.8 times larger than the Pauling values. The Pauling values, okay, electronegativity value according to Mulliken scale are 2.8 times the value in Pauling scale. So option third one option is the right option 2.8. Okay, right. Next question. Electronegativity on Mulliken scale is limited to, already discussed, Mulliken scale is applied to monovalent atom but does not cover multivalent atom. So here a monovalent atom, second one bivalent atom, third one both monovalent and bivalent atom, fourth one all multivalent atom. So Mulliken scale is applied to monovalent atom and does not cover multivalent atom. Okay, right. Next question, student. The values that are useful in writing chemical formula and in calculation of oxidation states are, okay, chemical formula and in calculation of oxidation state are: number one, ionization potential; number two, electron affinity; number three, electronegativity; number four, metallic characters. Here, more electronegative atoms accept electrons and get negative oxidation state. So the values that are useful in the writing the chemical formula and calculation oxidation state is electronegativity, because of more electronegative atom accept electrons to get negative oxidation states. Okay, third option is the right option, electronegativity. Okay, right. Next, reference element for Pauling electronegativity is a reference element, number one, hydrogen; number two, carbon; number three, fluorine; number four, helium. Reference element is hydrogen atom is taken. Reference atom is electronegativity value 2.1 value. So reference element is hydrogen. First one is the correct option. Okay, right. In a period, electronegativity is highest for chalcogens, halogens, inert gas, alkali metal. from left to right, periodic table, atomic size decreases, electronegativity increases. So halogen is more highest electronegativity value because of halogen have highest electronegativity as they get stable inert gas configuration by accepting one electron. So halogen, second one option is the right option. Okay. Okay, student, last question in this session. If I and E are ionization energy and electron affinity of an element in kilojoule per mole, electronegativity is given as according to Mulliken scale. Electronegativity is equal to IP plus EA by 544 kilojoule per mole. So fourth one is the right option, IP plus EA by 544. Okay, student. Thank you for listening the class in this session. Periodicity, ionization enthalpy, factor affecting of ionization enthalpy. Next, continue the class tomorrow will be continue. Thank you, student. Thank you, everyone, in this session, listening the class. Okay.